Hello, in previous videos you learned how to calculate the addition of vectors or resultant vectors when you want to add them by geometrical methods. I mean triangle method or parallelogram method. You also learned in that videos how to find the components of a vector by two methods. So here I'm going to explain when you find the components of vectors now how you can add them to each other. It is not difficult. Assume you have vector A again and vector B and you want to find the resultant vector of these two. So you have to find the components of A as I explained in the previous uh, videos. This would be the x component of vector A. This would be the y component of vector A, and you can write it A equals to ax I hat plus ay j hat. I hat and j hat are unit vectors, and as you can see, this perpendicular line hits the x-axis at 5, so the distance from origin from 0 to 5 is 5, so the x component is 5 I hat, and the y component, the distance of this point to the origin is 4 j hat. You can do the same for B, and as you can see here, the x component for B is -2, -2, and for B it is a -4. So when you want to add these two vectors, you should add the x component to each other and add y components to each other separately. So x components will make the resultant x component of the x component of the resultant vector, and the addition of y components will make the uh, y component of resultant vector that here I label it as S. So A plus B, 5 plus -2 and 4 plus -4. You can directly write 5 minus 2 because 5 plus minus is minus actually, or 4 plus minus is 4 minus. So what's the resultant? That is 3 I hat plus 0 j hat. So we have 1 0 here. What does it mean? It means I don't have any component along j-axis for my resultant vector or the summation of these two vectors. If you draw it on the on your graph here, you can see that vector S is this. Uh, do you like we check it with the other method like parallelogram method? Do you remember it? Parallelogram method was drawing two parallel lines, each one parallel to one vector, and the diagonal that you draw from the origin or the tails of that two vectors would be, as you can see, we validate our answer by using drawing method or parallelogram method. And if you have even more than two or three vectors, more than two vectors, three vectors, four vectors, you can uh, find the addition of first two and then use this method again for the third one for parallelogram method. But for the component method, that is easy. You just write vector C here under this and then write 5 minus 2 minus or plus something else. So this is an easy method to fast calculate the overall vectors of a large number of vectors.